Hello students, this is Mr. Ezra. Today we are going to talk about combining functions. You'll probably notice that the topics we cover today seem very familiar to you. They are things that we've talked about in the past, things that you should probably be fairly comfortable with, but we're going to talk about it in this idea of function notation and what it looks like in function notation. So we're going to add a little bit of a twist to it. So let's review what a function is, and this is something that hopefully you already know. A relation is any set of input that has an output. So relations can be any set of inputs that have any set of outputs. So I could say like an input of 2 and 3 have an output of 4, and both of those go to 4, and that's fine. It's a relation. 2 and 3 are a relation that go to 4 there. But a function is a special type of relation. A function is a relation such that every single input has exactly one output. Every x value is only tied to one y value. You might remember from previous classes that we can test a graph. If we have a graph, we can test whether or not it's function using the vertical line test, where we look from left to right, pass a line across a vertical line across the graph and see if it crosses the function more than once. And the reason it would fail if it crossed the function more than once is because you would have an input that had more than one output. It all goes back to this definition of what a function is. When you're looking at whether or not something is a function, remember that the x values can never repeat. They can never repeat. You can't have at 2 comma 3 and 2 comma 4. That's not a function because the 2's repeat, meaning that the input of 2 is tied to 2 different outputs, more than one output. All right, well, really today our interest is in function notation and kind of adding it to this idea of adding and subtracting and multiplying polynomials. So remember that function notation is just a way to name a function. You see this f of x right here. It is pronounced f of x. There is no operation there, no multiplication, no nothing. It's just a fancy way of saying y in an equation where we are naming the function the f function and saying that the variable inside of our function is x. So for example, instead of y equals 2x plus 4, we could say, and it would mean exactly the same thing if we wrote f of x equals 2x plus 4, where we're naming this function the f function and then saying that the variable inside the function is the variable x. That's the thing that we've plugged into the function. So we're going to start with some basic examples of combining functions. You'll notice we have an f function, f of x, and a g function, g of x. And we are asked to simply subtract g of x minus f of x. And I've gone ahead and kind of written in and highlighted some things so that you can see that we're basically taking the g function over here, which is 4x squared plus 5x minus 8, and then subtracting the f function, which is 6x squared minus 3x plus 5. So this operation of subtraction we're doing of those two functions in the order that they're written, and that's pretty much it. So remember from our last video that we have to distribute the negative. So we have 4x squared plus 5x minus 8. This negative is multiplied by everything in the parentheses that follows it. So we get minus 6x squared plus 3x minus 5. And now we're going to put together the like terms. So 4x squared minus 6x squared is negative 2x squared. 5x plus 3x is 8x. Negative 8 minus 5. Same signs, add and keep to get minus 13. So we got our answer in negative 2x squared plus 8x minus 13. So g of x minus f of x is equal to this trinomial right here. In our second example, we are given two new functions, a new f function and a new g function, and we're asked to multiply 2 times the f function plus 3 times the g function. So you'll notice that I took that f function and plugged it in 2 times that polynomial plus 3 times the g function's polynomial. And we have to multiply first, which means that we're going to distribute our 2 into the first parentheses and our 3 into the second parentheses to get 12x squared minus 2x plus 6 in the first parentheses. And then plus 3 is going to be like a positive 3. Positive 3 times x squared is 3x squared. And then positive 3 times 3x is 9x. Now we're going to put the like terms together. So 12x squared and 3x squared have the greatest exponent. We go first with them and get 15x to the second power. Take care of those guys. Minus 2x plus 9 is positive 7x. So take care of those guys. And then plus 6 doesn't have anyone to combine with, so it goes at the end, and we have our final answer for 2 times f of x plus 3 times g of x is equal to this trinomial, 15x to the second power plus 7x plus 6. Example 3, we have 2 new functions, a new f function and a new g function. And think about it this way. What if we had just used y for both of these? We just called them both y equals. And then I said 2 times y plus y. You wouldn't know which y I was asking you to use. When we have these different functions, we need to have different ways of naming them so that when we combine them together, we know what's what. And this function notation allows us to do that. It allows us to say, oh, the g function is this one right here, x squared minus 3. That's what I'm going to multiply 2 by. And then I'm going to multiply after that the 2 times the g function times the f function, which is 2x minus 4. So I've got this multiplication. Now, with multiplication, we're going to distribute the 2 first. You only distribute into the parentheses until the parentheses stops. So we're going to get 2x squared minus 6. And I'm going to put that in its own parentheses. And then we're multiplying that times 2x minus 4. And we're going to talk more about multiplication in the next video just to make sure that you remember it really well. But this is a binomial times a binomial, so we can just use that FOIL process that we've talked about before. We say first times first, first times first, outside times outside, inside times inside, and last times last. Come down here. So 2x squared times 2x is 4x to the third. 2x squared times negative 4 the outside times the outside is minus 8x squared. Inside times inside is negative 6 times 2x, which is negative 12x. And last times last is negative 6 times negative 4, which is positive 24. And since all of these are not like terms, they're all unlike terms, and they're already in descending order based on the exponent, I can circle my answer, and I am good to go with that one. All right, our final 2 examples for this video, we have an f function and a g function, and we're going to use this f function and this g function for question number 4 and number 5 because there's no new f and g defined for number 5. I should probably point out before we jump into this that we could, as many letters as we want to have, we could name functions with those letters. So we could have an a function, we could have a b function. We could use Greek letters and have a mu function. I mean, we could name it whatever we want using this function notation, and that's okay. We tend to use f and g just as kind of standards, f first and then g. It's just kind of normal. It's what we do. So in question 4, we're asked to add the f function and the g function together. So this is just adding 2 polynomials together, making sure that you take into account the like terms and the degree, adding the largest exponents first to get 4x squared plus x squared. Well, remember when an x or an x squared or an x to the third doesn't have a number in front of it, there's understood to be a 1 there, right? So this is like saying 4 plus 1 or 5x squared. Then we're going to combine together the x parts. So negative 2x plus 7x, negative 2 plus 7 is positive 5x. Different sign, subtract, and keep the sign of the larger one. So it's like saying 7 minus 2 is 5. And then 5 minus 8, same thing, different sign, subtract. So 8 minus 5 is 3, but we're going to keep the sign of the larger one, so we're going to keep it negative. We get our final answer, this trinomial, this quadratic trinomial of 5x squared plus 5x minus 3, when we combine f of x plus g of x. In question number 5, we're asked to multiply 4 times the g function and then subtract the f function. So we're going to multiply 4 first, that little coefficient in front of the g function, or that scale factor, whatever you want to call it, 4x squared. It's 4 times x squared. 4 times 7 is 28x. And then 4 times negative 8 is negative 32. So we've multiplied everything in there. Now, the second parentheses doesn't have a number in front of it, but there is a negative. And remember, anytime you're subtracting, it's like there's a -1 there that we have to distribute into the second parenthesis. So we're going to distribute here as well to get minus 4x squared plus 2x minus 5. And that just changes the signs in the second parentheses. Fix that x there. It doesn't look very good. 2x. All right, now we're going to put together our like terms. So we've got 4x squared minus 4x squared. Well, in this case, anything minus itself is 0, so they cancel each other out. Then I've got 28x plus 2x, which is 28 plus 2 is 30x. And then negative 32 minus 5. Same signs, add and keep to get minus 37. So after all of that multiplying and adding and subtracting, we end up with this smaller thing, which is a linear binomial. It's got an exponent of 1, so a degree of 1, making it linear, and then 2 terms making it a binomial. Well, we're going to wrap this video up, and I'll just mention that we're going to continue with the notes on combining functions in the next video. Wanted to just split this one up in 2 so it didn't get too long. Sometimes things can seem like they're taking forever. I will see you in class. Have a good day.